Groups. We have 18 groups. Groups in the periodic table are 18. Okay, 18 groups. Uh, in 18 groups, how they are arranged? Vertical columns. Okay, vertical columns, right? Vertical columns. So what groups are, what is the use of groups? These groups signifies the groups will give or signifies the valence electrons. Valence electrons means what are the electron number of electrons present in the outer shell? Number of electrons, yes, present in outer shell, right? Those are valence electrons, outer shell. Because most of the physical and chemical properties depends upon the valence electron, the way in which a element gives or donates or accepts the electrons. Okay, so groups are important because it says about the valence electrons. Okay, right. Let us see some example. For example, there is an element called as X. Okay, and it is possessing a number 12, atomic number 12. Okay, now I'll divide it into, how we will divide? 2, 8, 2, right? So how many electrons are there in the valence shell? Valence, how many? How many electrons are there in the last shell? How many electrons are there in the last shell? 2, right? So with the help of this thing, 2, it shares about, right? So its valence is 2, 2 electrons. If you have another element 8, okay, some element with the atomic number 8, how you can write? 2 comma 6. How many valence electrons are there? 6. Okay, if you have another element J with atomic number 18, okay, how many valence electrons it will have? 8, 8. So 8. This is complete. This is, it can take, okay, it is complete. Okay, in that way, it says about the valency. So if you know the valence electrons, you can say to which group it belongs to. We can say in which group it is belonging to. With the help of valence electrons, number of valence electrons will decide in which group it is in. Okay, that particular element is in which group. We'll see how it will work. Okay, right. Valence electrons. Valence electrons. Okay, valence electrons are up to 8 only. No, you cannot have more than that. Outer shell you can, yeah, yeah. So 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Okay, next, valence electrons. Next, group, with respect to that group, which group it belong to. Okay, if valence electron is 1 in a particular element, it will belong to group 1. Okay, if valence electron is 2, it will belong to the group 2. Okay, from 3 to 8, it will belong to the plus 10. Okay, that means what? If valence electron is 3, it will belong to 13th group. If valence electrons are 4, it will belong to the 14th group. Valence electrons are 5, it will belong to the 15th group. If valence electrons are 6, 16, and so on and so forth. 18, so till 18. So if you see the periodic table, how it will be? First one is this, he hydrogen, right? Like this, no, skeleton is like this, right? Okay, skeleton is like this. This is 1, 2, 3, 4, 5, 6, 7, 8 till 13. Again we start at 13. Okay, no. So 1, 1, 2, and 13, 14, 13 to 18. We only deal with S and P block, no. So that's why we are interested in these two. Okay, 1 to 13 to 18. This okay, right? So you need to add plus 10. If you have valence electron as 3, you can add plus 10. You can able to know easily which group it belongs to. Okay, right? Right. So now this is the significance of the valence. With the help of valence electron, we can able to say which group it belongs to. Okay. And with the help of period, what we can say? Number of shells. That is the very, very important observation. Okay. That's the reason we have divided our periodic table and arranged it in a specific manner. Okay, as we go it will become very interesting, because the direction will decide the properties, what properties and how it is behaving. Okay, from left to right, if you go in a period, how the chemical and physical properties are differing. From top to bottom in a group, if you are going from one element to the another element, from top to bottom, how the properties are changing. What is the relationship with the properties? There is an interesting relationship we can see. Okay, further. Okay, right. Let us move to the position. Now we'll see the position.